Hello there, and welcome to Abyssal Zenith, where curiosity settles in softly at the edge of night, and the strange, persistent mysteries of our world unspool slowly, gently, until the unknown feels like something you can almost touch. Tonight, we are going somewhere unusual. Not to the edge of space, not to the deep trenches of the Pacific, or the ice. Locked darkness beneath the poles. We are going somewhere much closer. A place you could find on almost any map of Europe. A place ships sail across every single day, ferrying cars and cargo and ordinary people between ordinary ports. It is a sea, a relatively shallow, relatively calm, remarkably well-studied body of water. And at the bottom of it sits something that has no satisfying explanation, something that does not belong there. Something that should not exist by any geology we fully understand. Something that has been measured, photographed, debated, dismissed, revisited, and argued over for more than a decade now. And still, no one can say for certain what it is. Before we sink beneath the surface of this particular mystery, I'd love to know, where are you listening from tonight? Are you in bed, in the quiet dark, letting the world slow down around you? Maybe the rain is falling outside your window, or the house has gone still and soft the way it only does very late at night. Wherever you are, I'm glad you're here. If this kind of gentle, unhurried exploration is something you find yourself returning to, I'd be deeply grateful if you'd like this video, or subscribe to Abyssal Zenith. It helps this small corner of science reach a few more curious minds who might need a quiet moment too. Now, make yourself comfortable. Breathe a little slower. Because the story we're about to tell begins in the Baltic Sea in the summer of 2011, with a sonar image that stopped a dive team in their tracks, and has not let go of the scientific imagination since. The Baltic Sea is not a dramatic body of water. That's not an insult, it's just the truth. It is one of the most enclosed, least saline, shallowest seas in the world. It sits between Scandinavia and the European mainland, connected to the North Sea through narrow straits, fed by dozens of rivers and cupped by countries that have sailed it, fished it, fought over it, and mapped it for centuries. It has depths, yes. Some parts plunge to over 400 meters, but by the standards of the world's great oceanic mysteries, it is a modest place, a predictable place, which is exactly why what happened in June of 2011 was so disorienting. A Swedish treasure hunting and shipwreck exploration team, Ocean X, they called themselves, was dragging a sonar scanner across the seafloor, somewhere between Sweden and Finland, looking for lost cargo. The kind of quiet, practical work that happens all the time on the Baltic. Nothing unusual about the day, nothing unusual about the water. And then the sonar image came back and showed them something that was, by any standard, unusual. A circular formation on the seafloor, roughly 60 to 70 meters in diameter. Sitting atop a raised formation, a kind of pillar or column of material, approximately 90 meters tall. The edges were not the soft, irregular edges you find in natural geology. They were distinctive, defined. There were what appeared to be straight lines, right angles, what some described as a staircase, like feature, or a corridor, leading into the structure's edge. Around the main formation, there were secondary features, smaller circular shapes, what looked like impact marks or scorch patterns, drag marks in the sediment, running from the formation in a long straight line. The sonar image, rendered in the grainy, monochrome language of underwater scanning, looked, and this is the word that started the conversation and has never quite left it, looked like the Millennium Falcon, the fictional spaceship from Star Wars. Now, that is not a scientific comparison. The team that found it would be the first to acknowledge the limits of what sonar resolution can tell you. Sonar builds shapes from sound reflections, not from light. Details blur, angles deceive. What the human eye wants to see it will sometimes find in even ambiguous data, but the comparison stuck. The internet found it. And suddenly, and within
a
weeks,
routine exploration
had a
team
new mystery.
had something far more complicated
When something
on their
strange
hands.
is found on the
They
seafloor,
named it the Baltic
there is
Sea
a predictable
object.
cascade of explanations. The most dramatic ones arrive first, amplified by media and social platforms, traveling far faster than any careful analysis. Then the scientists speak tentatively from the edges. Then come the formal studies, the dives, the sample collections, the months and years of patient investigation. And then, ideally, a conclusion. With the Baltic Sea Anomaly, we got most of that cascade, but not the conclusion. Let's walk through what was proposed. The first and most obvious suggestion was natural geology. The Baltic seafloor is not a featureless plain. It has been scraped and shaped by glaciers, redistributed by ancient floods, layered with sediment over thousands of years. The last great ice age left its fingerprints all over the Baltic basin. Retreating glaciers dropped enormous quantities of rock and debris, called glacial erratics, stones and boulders, transported vast distances from their original locations and deposited seemingly at random. Could the Baltic Sea object be one of these? A large glacial deposit, perhaps a particularly unusual arrangement of moraine, the material that accumulates at the edges and base of moving ice. It is a reasonable proposal, and it accounts for some of what was observed. Glacial deposits can be large. They can be irregular in ways that look almost deliberate. The Baltic seafloor has many such features, but the perfectly circular form of the main structure troubled those who studied the image carefully. Glacial deposits tend toward the irregular. They pile and smear and scatter. They do not, as a rule, produce clean circles 60 meters across sitting atop what appears to be a discrete pillar. The next proposal was volcanic activity. The Baltic Basin does have a complicated geological history, and some researchers pointed to the possibility of ancient volcanic formations, perhaps a remnant of a cone or vent, long since cold and silent, buried under sediment and forgotten. Certain volcanic features can produce roughly circular formations. Some kinds of geological extrusion create mound-like shapes, but there is a problem with this theory too. The Baltic's geology, as well as scientists understand it, does not strongly support the presence of this kind of volcanic feature in this location at this depth. The region is not known for volcanism. There are no nearby known volcanic zones that would naturally produce this kind of structure. The formation sits in a place where it should not be, by the maps we already have. A third explanation, one that gained significant traction in certain communities, was that the object was a man-made structure. Something built, something sunk, something deliberately. Could it be a sunken World War II installation? The Baltic was heavily militarized during both World Wars. Concrete structures, gun emplacements, anchoring devices, anti-submarine equipment, all manner of hardware went into these waters over the course of the 20th century. Could a circular concrete structure, part of some forgotten defensive installation, have settled into the sediment and presented this unusual silhouette? Possible, but the scale is difficult. A 60-meter diameter circular structure of that thickness would have been a substantial piece of infrastructure. It would be in the historical record somewhere. And then there was the theory that never quite left the conversation, even as researchers wished it would. The UFO theory. The Millennium Falcon comparison was, in retrospect, an invitation that could not be declined. The shape of the object, the apparent regularity of its edges, the drag marks in the sediment behind it, all of this was absorbed into a narrative that the object was not natural, not man-made in any conventional sense, but was instead evidence of an extraterrestrial vehicle, crashed or landed on the seafloor. This theory spread quickly. It made the Baltic Sea object famous in ways that purely geological curiosity rarely achieves. And it complicated every subsequent discussion of the anomaly, because from that point forward, any researcher approaching the subject had to first clear away layers of speculation before getting to the actual science. Scientists are used to this. It does not make it easier. But here is what's important to understand about the UFO hypothesis. And about all the other hypotheses too. None of them were disproven cleanly. And that is not because scientists were not looking. They were. The dive teams went in. The samples were collected. The measurements were taken. The analysis was done. And the object remained, stubbornly, what it had been from the beginning, unexplained. In 2012, the Ocean X team returned to the site with divers and cameras. This is where the story gets more complicated, and also where it gets stranger. The divers descended to approximately 87 meters, a significant depth, requiring careful decompression procedures, limiting bottom time, and placing equipment under real physical stress. The visibility was poor, as it often is in the Baltic, where sediment suspended in the water reduces how far light can carry. They found the object, and when they described what they found, the descriptions were not the ones that simplify a mystery. They were the ones that deepen it. The material of the object, they said, felt different from ordinary rock or sediment. It had a peculiar texture, described in various accounts as resembling soot or ash, or a kind of blackened granular surface, unlike anything they had seen in other Baltic dive sites. Samples were collected and sent for analysis. The analysis came back with an interesting result. The material contained a high proportion of limonite and goethite, iron oxyhydroxides, minerals that form through the oxidation of iron in the presence of water and oxygen. Now, these minerals are not exotic. They are found in all kinds of geological contexts. They form in sedimentary environments, in soils, in rust. Their presence alone does not tell us much. But the concentration and distribution suggested that the surface material of the object had been through some kind of process, oxidation, alteration, change. Something had happened to it. What exactly, that remained unclear. Then there was the electrical anomaly. This is the detail that tends to stop people. The dive team reported that electronic equipment near the object behaved erratically. Satellite phones cut out. Cameras malfunctioned. Dive equipment showed unexpected interference.
Is this accurate? Was it documented rigorously? Could it have been equipment failure, coincidence, the natural effect of depth on certain electronics? All of these explanations are possible. But the report of the anomaly was consistent enough across multiple divers and multiple pieces of equipment to attract attention. And it was, without question, the detail that the scientific community found most difficult to account for within any tidy framework. A geological formation does not typically interfere with electronics. A glacial deposit does not generate electromagnetic disturbance. Whatever was creating that interference, if it was real, was doing something that rock and sediment do not usually do. Here is where the story becomes a different kind of interesting. Because the Baltic Sea Anomaly is not just a geological mystery. It is also a sociological one. A story about how information travels, how expertise collides with speculation, and how a genuine unknown gets buried under layers of noise until the signal is almost impossible to find. After the 2012 dive, the coverage split in two directions that never truly reconciled. On one side, a wave of documentary films, internet articles, YouTube videos, and podcasts that treated the object as confirmed evidence of extraterrestrial technology, framing every unanswered question as a hidden answer and every expert's uncertainty as proof of conspiracy. On the other side, a gradual withdrawal by serious geologists and marine scientists who grew tired of having their measured observations twisted into something unrecognizable, who found that every time they offered a careful, qualified assessment of what might be happening on that seafloor, it was cropped and recontextualized until it said something they had never intended. The scientific discourse around the Baltic Sea Anomaly did not die, but it went quiet. And the quiet matters. Because what happens when a genuine scientific mystery becomes culturally contaminated is that the researchers who might otherwise study it in public start to prefer not to engage. The object becomes associated with fringe claims. Serious inquiry carries reputational risk. Funding is difficult to secure for something the tabloids have already declared solved, and gradually, the thing that needs explaining gets left in a kind of scientific no man's land, too strange for the mainstream to embrace, too real to simply dismiss. The Baltic Sea Anomaly lives in that space. It has not been explained. It has not been abandoned. It exists in the difficult in-between, where the most honest answer to most questions about it remains a carefully worded "we're not sure." And that in-between is where the most interesting science tends to hide. Let's go carefully through what we actually know from a scientific standpoint and where the knowledge ends. The Baltic seafloor is a complex place. During the last ice age, which peaked roughly 20,000 years ago, sea levels across the globe were dramatically lower than they are today. The Baltic Basin was not, in fact, a sea at all for much of this period. It was a landscape, tundra, forests, river valleys, occupied by animals and possibly by people, shaped by rivers and glaciers rather than by ocean water. As the ice retreated over thousands of years, sea levels rose, waters flooded into the basin. The landscape that had existed for millennia was submerged. What had been hills and valleys became underwater topography. What had been river sediment became seafloor deposit. What had been exposed rock became features that divers and sonar operators find today and try to interpret through the lens of the modern environment. This history matters for understanding the anomaly. It means that the object, whatever it is, did not form in the same conditions that currently surround it. It formed, or arrived, or was shaped in an environment that no longer exists. We are looking at it through the wrong lens if we assume it belongs to the Baltic as it is today. We need to think about it as part of a landscape that is now underwater, and that has been underwater for somewhere between 7,000 and 10,000 years. What would a natural formation from that era look like? What geological processes were active in the Baltic Basin as the ice retreated and the water rose? Could any of those processes produce a circular structure of this size and shape? The most scientifically grounded hypothesis that has been offered, and it is worth stating that this is a hypothesis, not a conclusion, is that the object is a natural formation related to glacial processes. Specifically, some researchers have proposed it could be a type of formation called a glacial drop structure. As ice sheets move, they carry enormous quantities of debris. When the ice melts, that debris is deposited. In some cases, the way ice melts can produce concentrated deposits, mounds, ridges, and in rare cases, roughly circular forms, depending on the specific geometry of how the ice fragmented and where the meltwater flowed. Could a glacial melt deposit create a structure this large, this regular, with this kind of apparent internal geometry? Possibly. In principle. But the circularity remains the sticking point. The regularity of the edges. The straight line features, these do not fit comfortably into the most common models of glacial deposition. Another geological proposal involves something called a pockmark. Pockmarks are craters in the seafloor formed by the release of gas or fluid from beneath the sediment. They are found all over the world's seabeds. They can be circular. They can be surprisingly regular. Some are quite large. But pockmarks are typically depressions, not raised structures. They sink into the seafloor. The Baltic Sea object rises from it. A third geological framework involves ancient riverbeds. Rivers, before the Baltic flooded, carved channels and deposited sediment in patterns that can sometimes look surprisingly geometric from above, or, in this case, from a sonar scan looking down. An ancient riverbed feature, partially buried, partially exposed, viewed from the wrong angle with limited resolution, could theoretically produce a profile that reads as more regular than it truly is. This is perhaps the most parsimonious explanation. The one requiring the fewest extraordinary assumptions. And yet, it does not easily account for the pillar-like structure beneath the main formation. Rivers deposit sediment. They do not typically leave 90-meter columns of material standing in one place. So the honest answer, the scientifically honest answer, is this: The Baltic Sea Anomaly is consistent with natural geological processes in some of its features and inconsistent with them in others. It does not fit neatly into any single known geological category, and without further detailed investigation, more dives, more samples, better sonar resolution, more thorough analysis, we cannot say with confidence what it is. We can say what it might be. We cannot say what it is. Let's sit with the unexplained elements for a moment. Not to feed speculation, but because honest inquiry requires acknowledging the things that resist easy framing. The circularity, a natural formation this large and this regular, is not impossible, but it is unusual enough that no geologist has been able to point to a clear analog and say, here, this is what it looks like when it happens. The comparisons offered are always partial, always qualified, always requiring some aspect of the Baltic object to be set aside or explained away. The pillar. The raised column beneath the main structure is genuinely difficult to account for geologically. What process creates a 90-meter pillar of material supporting a circular feature? Even allowing for the full range of glacial and sedimentary processes known to operate in this region, the combination is unusual. The straight-line features. Lines and angles in geology are not impossible. Columnar basalt produces remarkable geometric regularity, and there are other natural processes that create linear features. But they require specific conditions. Those conditions are not obviously present here. The drag marks. The parallel tracks in the sediment running from the object suggest, to some observers, that the object moved. That it was pushed, or dragged, or somehow displaced along the seafloor at some point. If this interpretation is correct, it raises an immediate question: what moved it? And from where? Natural displacement of a feature this size would require an extraordinary force. A landslide, perhaps. A very large iceberg dragging along the bottom as it drifted, but the directionality and apparent length of the tracks are difficult to reconcile with these explanations. The electrical interference. This is the hardest element to evaluate, because the documentation is limited and the variables are complex. Electronic equipment behaves unpredictably at depth for many reasons. Pressure, salinity, temperature, vibration, all can affect performance. But if the interference was genuinely localized to the vicinity of the object, that is not something a rock formation easily explains. Rock does not generate electromagnetic fields. It does not produce interference patterns. Unless it contains something that does. Some minerals are naturally magnetic. Iron-rich rocks can produce measurable magnetic anomalies. And the material analysis did show high iron content in the surface of the object. Is it possible that a highly concentrated deposit of magnetic mineral, shaped by unusual geological processes, could produce local electromagnetic interference strong enough to affect electronic equipment? Possibly. But this remains unverified. No formal magnetometric survey of the site has been published. The magnetic properties of the object have not been rigorously characterized. And so this, like so much else about the Baltic Sea Anomaly, sits in the space of plausible but unconfirmed. There is something deeply uncomfortable about that space for scientists and curious observers alike. We are used to progress. We expect that if we send divers to a site, collect samples, take measurements, and run analyses, we will emerge with answers. We expect the unknown to yield, eventually, to method. But some unknowns are more stubborn than others, and some are stubborn not because the truth is extraordinary, but because the effort required to establish even an ordinary truth is larger than anyone has yet been willing or able to invest. This is the question that comes up again and again in any discussion of the Baltic Sea Anomaly. It seems simple. The object is known. The coordinates exist. The Baltic Sea is a relatively accessible body of water, well within the reach of scientific research vessels. The depth is challenging but not extreme by the standards of marine science. Why hasn't a major, well-funded scientific expedition gone back? Why hasn't this been resolved? The answer is more complicated than it looks. Money is the first constraint. Scientific research funding is intensely competitive, and the allocation of limited resources toward a particular project requires making a case for that project within the priorities of the institutions and agencies that hold the purse strings. For a formation that might, and the word might carries enormous weight here, be nothing more than an unusual geological deposit, the case for major investment is not automatically compelling. The Baltic Sea has many other scientific priorities. Its ecology is under pressure from pollution and climate change. Its fish stocks have declined. Its oxygen levels in deep water have dropped dramatically. These are pressing, urgent problems with clear human consequences and strong scientific communities advocating for resources to address them. A possibly unusual, possibly interesting, almost certainly geological formation on the seafloor competes against all of this for attention, funding, and ship time. Reputation is the second constraint. This is the consequence of the cultural contamination we discussed earlier. When a geological feature becomes famous primarily as a UFO site, the researchers who might otherwise investigate it must weigh the professional cost of being associated with a topic that carries, in many scientific circles, significant stigma. The most rigorous scientists are often the most careful about where they place their professional credibility. This creates a paradox. The people best equipped to resolve the mystery are often the least willing to publicly engage with it. And the people most willing to engage with it are often the least equipped to resolve it. The third constraint is practical. A serious scientific investigation of the Baltic Sea anomaly would require not just divers but a coordinated program. High-resolution multi-beam sonar surveys, ROV inspections, coring to retrieve undisturbed sediment samples from the structure itself and from the surrounding seafloor for comparison, magnetometric surveys, chemical analysis, dating of materials to determine when the structure formed or was deposited. Each of these components requires specialized equipment, specialized expertise, and time aboard a research vessel. Assembling all of it, in coordination, focused on a single site, requires the kind of sustained institutional commitment that is difficult to generate without a clear scientific hypothesis and a reasonable expectation of publishable results. And the hypothesis, as we have seen, remains unclear. We do not know enough about the Baltic Sea object to design the definitive experiment that would resolve it. And we cannot design that experiment without the kind of detailed preliminary investigation that itself requires resources. It is another circular problem, not unlike the ones we encountered beneath the Arctic ice. We need data to plan the mission. We need the mission to get the data. Science moves forward anyway, incrementally, imperfectly. But it moves slowly in places where the unknowns are layered and the incentives are complicated. And so the Baltic Sea anomaly waits. On the seafloor. In the dark. In the cold. Sitting in its coordinates, unchanged, indifferent to our uncertainty, as patient as stone. There is a tendency, when we encounter a mystery that resists explanation, to reach for the most dramatic possible answer. If geology can't explain it, it must be something beyond geology. If science is uncertain, the uncertainty must be covering something science is afraid to admit. This is a deeply human impulse. We are pattern-seeking creatures. We prefer complete stories to incomplete ones. We find comfort in explanation, even wrong explanation, more than we find comfort in honest uncertainty. But the Baltic Sea anomaly is worth sitting with precisely because of that uncertainty. Not because it might be a crashed spacecraft. The evidence for that interpretation is, to put it plainly, non-existent. But because the genuine scientific uncertainty around it tells us something true and important about the nature of our knowledge. We have mapped the surface of Mars in greater resolution than we have mapped the seafloor of our own oceans. Read that again. We have mapped the surface of Mars in greater resolution than we have mapped the seafloor of our own oceans. The oceans cover 71% of the Earth's surface. The average depth of the global ocean is more than 3,600 meters. And the detailed, high-resolution mapping of what lies on that seafloor, the topography, the geology, the features that might tell us something profound about the planet we live on, remains, in many areas, shockingly incomplete. We tend to assume we know our planet. We have satellites. We have GPS. We have centuries of navigation and exploration. The Earth feels known. But the seafloor is not known. Not really. Not in the way we know land. The Baltic is better mapped than many ocean basins, and yet a 60-meter circular formation sat on its floor for, we don't know how long, before a treasure hunting team stumbled across it with consumer-grade sonar in 2011. What else is down there? The answer to that question is, more than we have imagined. The deep seafloor is littered with features we do not fully understand. Underwater mountains that exceed Everest in height measured from their base. Vast lava plains the size of continents, formed by volcanic events with no parallel in human experience. Fields of hydrothermal vents hosting ecosystems we are still learning to describe. Crater-like depressions of unknown origin. Mounds and ridges and channels and formations that our models of geology do not yet fully account for. Tonight is the Baltic Sea Anomaly is not exceptional in being unexplained. The ferries are still crossing. The fishing boats are resting in their harbors. The water is doing what water does, flowing, cooling, circling, settling. And somewhere in its middle depths, between Sweden and Finland, a circular formation sits on the seafloor, as it has for as long as it has existed. Not speaking, not revealing, not hiding, exactly. Just being what it is, in the way that stones and water and time simply are. We do not know what it is. We may know, one day, or it may remain one of those quiet questions that the world keeps for itself, a small, dark, underwater mystery, significant not because of what it answers, but because of what it teaches us about asking. Thank you for spending this night with Abyssal Zenith. If this kind of gentle, curious exploration is something that helps you rest or settle or simply feel a little more connected to the strangeness of the world, I'd be grateful if you'd share it with someone else who might feel the same. Sleep well, wherever you are. The Baltic will still be there when you wake up, and so will its questions.